The automated ball indentation, or ABI test, is performed using Advanced Technology Corporation's stress-rated microprobe mobile system. This is a mobile system was specifically designed to perform the ABI test. The ABI test measures the tensile and fracture toughness properties of metal components. It is non-destructive, fast, and accurate. The ABI test results are within 5% of the results from destructive tensile specimens and within 10% of the destructive fracture toughness tests. The ABI test was invented 25 years ago as a field test and to replace the destructive tensile and fracture toughness test. It is very well suited for the petroleum industry, where an oil or gas pipeline can be tested in service and under pressure. The ABI test is not affected by the operating pressure. Furthermore, there is no need to cut and weld sections or use hot tapping to extract discs to machine destructive specimens. The ABI results can be reported within hours, not days or weeks, so that the excavation can be closed quickly. Using ABI testing saves you time and money and safer for people and the environment. ABI tests can be performed with minimal surface preparation. The smallest area for the mobile footprint is approximately 12 inches by 4 inches. All coatings and residue must be removed from the pipe surface by sandblasting. To prepare the area for testing, the technician will smooth the surface with a 120 grit sanding disc. Then he will have another disc to polish 220 grit to polish a 2-inch diameter area for a smoother surface finish for the test. The SSM mobile system consists of these components: the electronics cabinet, which is actually lithium-ion battery operated and has signal condition motor control data acquisition, and then a netbook computer, and the portable load frame, which actually uses DC magnets to attach that load frame to the pipe. And also the sensors we acquire the data is a load cell and a high precision depth transducer spring-loaded LVT. And of course we have the tungsten carbide ball antenna over here inside that chuck. And then we have the motor and the actuator moves that crosshead. This is a demo of an ABI test on a pipeline section. So we start the test by typing the test name. Now we are bringing the antenna to contact the test surface to apply the multi-cycle indentation with the intermediate partial unloadings. So once the antenna is going to be applying the preload, the test is going to temporarily stop so we can go to the next phase of the test with the cyclic loading with intermediate partial unloading. So now it's applying the preload, and you're going to see this number increase until it reaches 12-pound preload and will stop. Now it is applying the preload, automatically stopped. We're going to continue. Now we're going into the real-time display of indentation load versus indentation depth. And these are digital display of the actual value of the load and the actual value of the depth in mils, thousandths of an inch. And the third digit is millionths of an inch. And now showing the cycle number as going. Now it's loading and then goes to unloading. And now it's in cycle 8, where it's going to fully unload the antenna. And once the antenna is fully unloaded, then we hit the return button to save the data, and now we analyze the data and we select that test and do a few steps, and the software will take care of all the calculation and is doing both the tensile plus fracture toughness. And now the analysis is fully completed, so we can look at the report, give you all the digital values of the yield strength, estimated ultimate and fracture toughness, and also show you the results by cycle. Okay, and the whole thing is fully calculated. Then we can actually look at the summary of all the tests. We usually do like 3 to 5 tests, so we can actually look at the summary and get the average and the standard deviation from the tests we ran, so that we can move into another test location. So here, for example, the average from these 3 tests was 60 KSI for the yield, and a standard deviation of 0.6, same thing for the estimated ultimate, same thing for the fracture toughness. So this is excellent data, so we are finished with that test.
طيب.
There are several key benefits to the ABI test. As a non-destructive, the ABI technique is ideal for testing in-service components where cutting samples is either too costly or impractical, such as pipelines. Also, the spherical indentation produced on the pipe surface are smooth, shallow depressions with no sharp edges or stress concentration sites. Also, the ABI test is very efficient. The ABI measured the yield and ultimate strength values are obtained in minutes for fast grade determination, so as the fracture toughness as well. Also, the tests are performed on in-service pipelines, so there is no costly transmission loss or downtime. We have performed thousands of ABI tests on oil and gas pipelines for numerous clients worldwide for over 15 years. The in-situ non-destructive ABI tests have enabled our clients to assess the integrity, determine the grade, and determine the maximum allowable MOP for their pipeline assets. This system is accurate and reliable and has provided operators with data critical to their structural integrity management programs. Thank you.